Okay, as we edge ever so closer to gas stoichiometry, there's one thing I need to teach you guys about the volume of a gas. Now, in the previous video, I just explained to you that as long as the pressure and temperature are constant, then the volume of the gas, regardless of what the gas is, and regardless of how big or small it is, will be the same. Now, if we are at standard temperature and pressure, you guys all know that standard temperature and pressure are 0 degrees Celsius, which is the same thing as 273 Kelvin, and 1 atmosphere. 1 atmosphere, again, is sea level. That is exactly equal to 101.3 kilopascals or 760 millimeters of mercury. All of those are the same, and those are standard temperature and standard pressure. Now, if that is the case, then again, it doesn't matter the gas that we're talking about. 1 mole of a gas, or to say that another way, 6.022 times 10 to the 23rd molecules of any gas is going to take up an exact volume of 22.4 liters. Again, this number is given to you on the formula chart. If you go on to the constants and equations page, go to the backside or the second page, and you'll notice down near the middle of the page, it says that 1 mole of a gas is equal to 22.4 liters. Again, that is a constant. It is provided to you on the formula chart. So if that is the case, then let's go ahead and try number 8. It says, how many moles of oxygen gas are contained in 135 liters of oxygen at STP? Again, this is important. It must be at STP, because if it's not at STP, this does not work. But I'm going to start with my 135 liters of oxygen, O2. Then I'm going to go ahead and convert out of, again, this is just dimensional analysis, guys, liters of O2. And they want us to solve for moles. Now, I can go directly from liters to moles. And again, the reason I could do that is, of course, we were given the conversion factor right here. Because we do know the conversion factor, this is a completely legitimate one-step, quite simple calculation. Again, assuming it's at standard temperature and pressure. If not, again, this does not work. So according to the rectangle, I just put a box around up above, for every 1 mole of any gas, in this case oxygen, that would be equal to 22.4 liters. Again, that is a constant regardless of the gas. So using my calculator, I'm going to type 135 times 1 divided by 22.4, and I get my volume of oxygen, or excuse me, moles, would be 6.027 moles of oxygen. So that's how many moles or quantity of oxygen molecules in 135 liters of oxygen. Now, to be honest, the fact that it's oxygen makes no difference on this problem. This could be any gas. It doesn't matter that it's oxygen. This could be anything. If I have 135 liters of a gas at standard temperature and pressure, it will always equal 6.027 moles of that particular gas, because again, it's a constant. All right, the next one we have is 35 liters, again, of nitrogen, but it doesn't really make any difference because, again, we're at standard temperature and pressure. What we're trying to get into is grams. So I'm going to put liters of nitrogen here. Can I go directly into grams of nitrogen? Do I know the conversion from liters into grams? Unfortunately, I do not. That is not a constant because remember, as you learned last semester, the mass of every element is completely dependent on the element itself. So to do this, I'm going to have to first go into moles, okay, just like number 8. That is not going to get me all the way to my finish line, so I'm going to have to do one additional step. I'm going to put moles of nitrogen down here, and then I can go from moles into grams because, again, we've been doing this for months. All right, so moles of nitrogen will cancel out, and we will be left with some amount of grams of nitrogen. So this is basically like number 8. I just had to add an additional step. So for the first conversion factor, for every 1 mole, it is going to be equal to 22.4 liters. Again, doesn't matter that's nitrogen. It would be true for every single gas that there is. All right, then for grams over moles, the moles is going to be equal to 1. Grams comes from the periodic table. If I take the mass of nitrogen, multiply it by 2, it's 28.014. I'm going to go ahead and multiply all this together. And I'm going to divide by 22.4 and divide again by 1. And I get my answer in grams, not moles, but in grams of 43.772 grams of nitrogen. So like I said, number 9 is very similar to number 8, only that we didn't stop at moles. They wanted us to push all the way to the next step of grams. No big deal. All right, number 10. We are starting with, again, 11.2 liters of hydrogen gas, that's H2. And we're looking for how many moles at STP. So to cancel out liters of H2, I'm going to put liters of H2. I'm going to go ahead and put moles of H2 because, again, we do know the conversion factor at the very top of the table, over the page. I know that for every 1 mole, is 22.4 liters of that. Since they want us to solve for moles, we're done. That's all there is to it. It's going to be, well, I could do that in my head. 11.2 divided by 22.4 is going to be half a mole of hydrogen, or any gas for that matter. Okay, guys? So that is a very special condition if we're at standard temperature and pressure. The volume of any gas, of 1 mole of it, that for, I gotta say that, for 1 mole of it is 22.4 liters. Okay, we do have one more, so let me go ahead and I'm gonna knock this one out as well, just for you guys. You guys have it for your notes. Okay, so what we've given here is 33.4 grams. 34, did I say 33? 34.0 grams of NH3. Okay, so I already know that I'm going to have to go out of grams of NH3. And the only place I could really go is into moles of NH3. Okay, because I know that conversion factor. Then I'm going to move moles of NH3 down here to cancel that out because that's not what we want to finish with. They want to know what volume. So volume is liters of NH3. Okay, so grams of NH3 will cancel out. Moles of NH3 will cancel out, leaving us with some volume of NH3 or ammonia. So again, whenever moles is on top of grams or vice versa, the mole's always 1. Grams come from the periodic table. Give me a second as I add up this mass. It is 17.031 grams. Again, that came from the periodic table of 1 nitrogen and 3 hydrogens added together. Then on the right side, the last conversion, I know that for every 1 mole, it is always 22.4 liters. Pick up my calculator. 34 times 1 times 22.4 divided by 17.031 divided by 1. And I get my final answer of 44.718 liters. Now, in this case, that is not true for every single gas because, again, we're given a mass. Because we're given a mass of ammonia, that changes things because, remember, the mass of ammonia as a gas would not be equal to the mass of other gases. So I cannot say as a blanket statement that if I have 34 grams of any gas, it's going to equal that much volume. That is not the case, okay? All right, guys, that again is how to convert volumes and moles, or vice versa, if and only if we are at standard temperature and pressure.